Okay, guys, the previous one was spoke about the basic time graph and the basic cost graph. Okay, we're going to do the same thing for tan now. So the first point that we made was know the basic trig graphs, the shapes of them, and be able to identify them. So I'm just going to write here. So this would be, we can make it step 2, I suppose. So 1 is on the previous note where we had the same heading, right? So I'm just going to write the basic tan graph. To know the basic tan graph and be able to identify changes to the shape. Right, if we know what the tan graph looks like, but we then see, okay, if something is different here, then we can figure out what is different in the equation as well. So guys, like we did for sine and cos, I'm just going to draw the basic tan graph. So this equation is y equals tan x. And I'm just going to draw it from 0 to 180. So guys, when we normally draw a tan graph, we know that the period is 180, right? It's different from the other two in that sense. So I'm going to write on the side here, period is equal to 180 degrees. So then we get our step from that, right? The step is always the period divided by 4. So S is going to be 180 divided by 4. So the step is 45 degrees. So now when you're drawing your x-axis, you need a notch at every 45 degrees. I'm just going to fill those values in. So we can do these notches here as well. So we have our axis, obviously, this is where x is 0, then we have 45, we have 90, 135, 80. And guys, you can use the table function, obviously. If you're not sure of how to draw this one, but it would be better if you knew the shape of the basic one. Okay, it's much easier to identify changes to it if you're not relying on the table on the calculator all the time. So if you just know what this one looks like, then you'll be able to see, okay, this is different, this is different. Okay, now for the normal y equals tan x graph, if you're going from 0 to 180, you're going to have an asymptote at 90. Okay, so that's the first thing that we're going to put in. We have our asymptote at 90 degrees. And the equation of that asymptote, if they're asking you, is x equals 90 degrees. Okay, I'm not asking you down this way, so let's write it in. Then guys, the tan graph is similar to a sine graph in the sense that it starts at the origin. Remember when I say starts at starting point, I'm thinking of the y-axis, what's happening on the y-axis. Okay, now the tan graph has a point at the origin. The next point is then at 45, 1. From there, it's going to go up towards the asymptote. On the other side of the asymptote, at 180, we have a point of negative. But we have a point at 135, negative 1. From 180 to 135, it's going to go down towards that. So guys, things that can now give us maybe tips of, okay, this is not just y equals tan x, this is something else. Is if your point at 45 is not at 1, but if it's at 2, or at 3, or at negative 1, or negative 2. Alright, so I'm going to write that down now. But that is something that you need to kind of memorize, alright? The starting point is at the origin. Your next point is at 45, 1. Okay, so I'm actually going to list those things here. Starting point is at 0, 0. The next point is at 45, 1. Then you have an asymptote at 90. Then you have a point at 135, negative 1. And then the next point is going to be at 180 and 0. So guys, if that is not the case, if you don't have those points, then the equation is not just tangent. You need to remember that a tan graph doesn't have an amplitude. So we won't be able to use the amplitude formula to calculate A. Right? That makes this one a little bit more difficult. So write down there, please, tan graphs do not have amplitude. Therefore, cannot use amplitude formula to find A. Now guys, if we want to like number our points, right? Let's say that each point has a number. So if we want to say, for example, this is point 1, the starting point, the point that's normally at the origin is point 1. The next point is point 2. Okay, because I'm going to talk about point 2 now. Point 2 is always what's going to give you your A value. All right. The y coordinate of point 2 is your A value of a tan graph. Okay, unless it's shifted up or down. We'll look at examples now. So therefore, y coordinate of point 2 is the A value. unless the graph has moved up or down. It's not very complicated, but when you do examples, it's not actually that bad. Just need to write down there a little example. And guys, if your graph moves up or down, right? If it didn't, you can just identify the second point, which also, the second point is not always going to be at 45. Okay, so you're going to have to find your starting point, your point that's on the y-axis. Then you're going to have to see the next point, that's point 2. Okay, if the period has changed, or if the graph has shifted to the left or the right, your point 2 is not necessarily going to be at 45 degrees, but it's going to be this point, right? That one over there, that is point 2. You want to maybe label it on your graph as well. That is the point that's going to give us our A value. Okay, the y coordinate of that point. So 1 in this case. Our A value here is 1. Okay, so if your graph did not shift up or down, and again, that's something that you'll be able to see quite easily. Because this origin point is not going to be at 0. It's going to be at 1 maybe, or at 2, or at -1 or -2. Then you know that it shifted up or down. If it's not shifted up or down, you're just going to look at point 2. The y value of that point is your A value. So like we wrote down now. If the graph has shifted up or down, what you're going to do is you're going to look at the distance between point 1 and 2. All right, so we can maybe make a 1 here as well. So you're going to look at the distance between point 1 and 2, but not like that, right? We're not going to do like distance formula or something. We're just going to look at how many units higher or lower maybe, right? Is point 2 than point 1. You see that it's 1 unit up. Point 1 is at 0, point 2 is at 1. So our A value is 1. Okay, I'm going to write that down, but just while we're still looking at the picture, if your graph shifted up or down, we can actually use this method always, all right? But if the graph shifted up or down, you're going to have to look at the distance between point 1 and point 2. Point 1 is 1 unit above. All right, point 2 is 1 unit above point 1. All right, this one is at 0, that one is at 1. So your A value is 1. Okay, so let me just write that at the bottom here as well. I'm going to make it a new point because that seems a bit long. If the graph moved up or down, then I'm going to write it as a formula. A is equal to y of 2, y of point 2, the y value of point 2, minus the y value of point 1. So that is basically the distance between the two lines. We'll do examples and then we'll apply all of these things. Maybe then it will be. But guys, you can use this always actually. Okay, if you don't want to look at the y coordinate or if you can always do this. So A value for tan graph will always be the y value of 0.2 minus the y value of 0.1. That's always. All right, so we've spoken about y. No, A. Sorry, I was talking about y. We've spoken about A. Now that A can sometimes be negative as well, but if you use this formula, you will always get that. Okay. And if you're using this, if your 45-degree point is at -1, then your A value is -1. Okay, what else is happening here? What else do we need to look out for? Obviously, whether it's shifted up or down, you'll be able to see that on the graph. Okay, so I'm not going to write a note for that, but there might be a Q value. If the graph shifted up, your Q is going to be positive. If the graph shifted down, it's going to be negative. Let me write that down here, but that's just something that you're going to have to look at. Okay, it's not, there isn't really a formula for that. If graph moves up, then you're going to have a plus Q. at the end of your equation. It's going to be like tan x plus 1. And if the graph moves down, then you're going to have a minus 2, right? And negative q back. So it's going to be like minus 1 or minus 2 or whatever. But like I said, that's something you just need to try and stick by looking at the graph. To find your k value, we're going to do the same method as we did for the time close. But the formula that we use is going to be slightly different. All right, the period of a tan graph. What is the normal period of a tan graph? 180. So we're going to use 180 over k. All right, for time close, we did 360 over k. For time, we need to remember that the period of a tan graph is 180. So we're going to do the same method, guys. We're going to identify what is the period of the graph by looking at the graph. All right, so we're going to see from one point at 0 to the next point at 0, for example, what is that distance? Okay, so if we're looking at this graph here, normally we look from asymptote to asymptote. If they're just giving you this bit, we don't have the other asymptote. All right, so we need to look at what is the y value of this point is at 0. Where is the next point at 0? 180 degrees further on. Okay, so you can always look at it that way. So from 0 to the next 0, that's 180, that's one period. Or maybe if they drew the next one point here, you would say from 1 to 1, that's 180. From -1 to -1, that's 180. From asymptote to asymptote, that's 180. That's the period. Okay, so for the time graph, it's a bit easier to see the period, I think, than for the others. So I'm just going to write here from asymptote to asymptote. If you have two asymptotes, you can just see what's the distance between the two, and that will be your period. That's normally the easiest way to see for time graph, but they don't always give you two asymptotes. Right? So that would be one option. You can look from one asymptote to the next asymptote. What is that? How many degrees? That would be the period. Or you can go from one 0 point to the next 0 point. Or from 1 to the next one, and one -1 to the next -1. You guys know what I mean when I say 1 point, okay? From 1 to 1, like the y value. So if I'm looking at this, that point has a y value of 1. So the next point with a y value of 1, that distance will be the period. Okay, that's what I mean by that. So from one point, let's just use a hyphen to the next. Or last one, sorry, from one -1. Just use that. Those are all the different ways in which you could find the period of your graph. And once you've identified the period of the graph that they've given you, you need to put that period into this formula and then solve the case. I'm going to just add here. If the period of the graph that they give you is 180 degrees, right? If you look at the graph and you're using any one of these four methods, and you're seeing, okay, the period is 180. That's the normal period of a tan graph, right? So if the period is 180, then you don't have to go through all the efforts of still solving for k. Then k is just 1. All right, so if the period is a normal period, there was no different k value. You didn't change the period, the k value is just 1. Okay, so that could maybe save some time. Then the last thing, the p-value, guys, to get your p-value, always look at how is your origin point shifted to the side. Okay, so that's the only thing you're going to look at. The origin point, right? The starting point, the 0, 0 point. If that point is at 45, 0, right? If you have a point there and then it's going up, then your graph has shifted 45 degrees to the right. Or if it's at like 30, then you have a p-value. Okay, so that's the last thing that we're going to write in the note on. To determine p, so that's not a value in that bracket, right? If your graph has shifted right, you're going to look for the starting point. Point 1, which is normally 0, 0. If that point has moved to the side, then you need to figure out what your p-value. So if it is, for example, 30 degrees and 0, then you're going to have in your bracket x minus 30. I haven't spoken about it in a while, but remember if your graph is moving to the right, you have a minus. Right, if your graph is moving in the positive direction, there's going to be a minus in the bracket. But if that starting point is, say, at negative 45, these are just two numerical examples, so you can see how it works. So if it's at negative 45 instead of at 0, right, it moved 45 degrees to the left in the negative direction, then in your bracket, you're going to have x plus 45. Okay, there is an exercise in the textbook which is a bit strange in the way that it's given. So you know, I'll put it on the board. Now they've given, I'll put the picture on the board now, but they've given 5 graphs on one set of axes. But what they've actually done is they've written multiple equations above the table. And from the 11 equations that they've written above the table, you need to identify the 5 that are on the picture. Okay, so they've actually given you all the equations, but you need to pick out which one goes with which graph, if that makes sense. I'll show you now. Quickly finish copying that down so that I can put the picture on the board. Okay, so this is what the picture looks like. All right, that is the picture. So there are 5 different graphs. So they've given you the letters on the side. It is quite small, so it's better if you guys have your books with you and you can actually look in your books. But they are telling us that that one is G, that one is H, that one is K. The green one over there is F. Guys, if we're looking at F, and we see that that is a tan graph, right? F is a tan graph, definitely. So there's one part of F. There is another part of F, right? Do you see that green bit? And that green bit over there is another part of F, right? Remember, a tan graph is like that. It's almost like split up into parts by the asymptote. Okay, so you have to find the equation of F. You have to find the equation of G and of H and of K, and then there's supposed to be another one. Oh, that one down there at the bottom is T. Now guys, do you see what I'm saying? It's obvious that this one has moved down. Alright, so you just need to figure out what type of graph is that? Is that a sine graph or a tan graph? And apart from moving down, this other things also happen to it. Okay, so I actually think what I'm going to ask you to do is to not look at the equations that were given, because some of them, I remember, some of them are a bit strange. I actually just want you to find the equations of these 5 graphs. All right, so I'm going to freeze that, and I'll just write down the letters next to them, because the letters are a bit difficult to make out. So this one is T. This one is H. That one is 5. The tan graph is F, and then this one is T. So wait, we are all put this K. K is this one. Okay, but K and T over there, they K is that. So that's good. So I'm back to see if you can find those equations. One of them are quite tricky, but they're not all really bad. These back is negative 45. Right, goes on the back of the so if you can't read that, it's different 15 degrees. Okay, right, if you haven't trouble reading what those lines are. Okay, is that now for you guys? And it's report it in, and you can actually just mark it as well. Yeah. Yes, yeah. Then, guys, what is the issue with reflective learning? Why are there so many of you that didn't do it? It's like more than half the class. Either it's not coming up on my website in the way that it should, but it's 1, 2, 3, 4, 5, 6, 7, 8, 9 of the 14 of you. So the people that so I'm just going to read out names, and if you did actually do it, then you must just come show me, because it's not showing up on my page. But Jade, Tinashe, Alia, Taskia, Imad, Aviwe, Seb, it's showing that you haven't done anything. No numbers, no fractions. Daniel, and then Sophia, also nothing. So if you guys have done that, you can come show me now, please, so that I can tick you off here. Yeah. Yes, yeah. Otherwise, you're getting writing out. So come show me evidence, or you're writing out.